Section 1.4 is getting into transformations, shifting, reflecting, and stretching graphs. And we'll do more with this later too, especially with trig functions. This is just kind of that reminder of transformations. We'll kind of look back at our parent functions, use vertical and horizontal shifts to sketch graphs, use reflections to sketch graphs, and use non-rigid transformations. So that non-rigid might be some new vocab, but I think you'll find that it's actually something that you've already talked about before. So kind of your summary of some parent functions. Remember, your linear function is just that y equals x. You have your absolute values, your square root, your quadratic, your x squared, your cubic, which is your x cubed, and then your rational function, which is that 1 over x. So horizontal and vertical shifts, something to remember when we're talking about transformations. So just a little side note with transformations. Is that your x's, I always say that your x's lie. So whatever it tells you is happening to the x is actually the opposite. But whatever you think is happening to the vertical values or your y's is telling the truth. So if you have a vertical shift up and your function, you have your function, and then we have this plus c on the outside, it's actually going to go up c. Vertical shift down would say minus that constant. However, if we're inside that parentheses, so if it's being applied directly to the x, and it says x minus c, you would think it's moving to the left c, but it's actually going to the right. So your x's are lying to you, but the y's tell the truth. So for this first example, we're going to use the graph of g of x equals x cubed. So that's, remember, your cubic function. Right, so that one just kind of looks like this. And to sketch a graph of x cubed minus 1. So that minus 1 isn't applied to the x because it's not also being cubed. So this is just going to shift down 1 unit. So if you were to sketch that graph where it shifts down 1, now instead of crossing at 0, 0, it will cross at 0, negative 1, and it would go more like that. If again we took that same cubic function, but this time we have the x minus 1 and it's a quantity cubed, this is being applied to that horizontal value. It says it's minus 1, but we know the x's are doing the opposite, so this is going to the right 1. So we would take that same cubic function, but now again, instead of crossing at the origin, it's going to cross over at that point 1, 0. And then c, we have a couple things happening. So this x plus 2 means that it's going to the left 2, and then it's going up 1. So that point that was at 0, 0, again, pick that point and then apply the transformation. So if we need to go left 2 and up 1, that origin where we started now has shifted here, and then you have that cubic graph that goes through there. So writing equations from graphs. So this one is recognizing what your parent function is, and in this case they tell you it's x squared, and deciding what has happened. So again, remember your x squared graph, and that starting point is at 0, 0. So the first thing to look at is where did that vertex shift? And so in this case, and then something else is that we always have that point 1, 1. So see if we're still shifting over 1 and up 1. So that 0, 0 shifted up to the point 0, 4, and then we're still having that symmetry here. So this is really just shifting up 4, which means to write the equation for our function, we have f of x. Oh, nope, they tell us it's g of x. We need to use the correct name. So we would say that g of x is x squared and then plus 4, because we want that 4 to not be tied to the x. That's a vertical shift. So here we have the function h of x, and we can see that it shifted to the left 2, and then it shifted down 1. So we would say that h of x To the left 2 means in parentheses we're going to say x. It would seem like we should say -2, but we're going to do opposite. So +2, we'll shift it to the left 2, and then down 1, we'll subtract 1. All right, so now if we look, our graph is upside down. So now we have to reflect it so it's down. And remember, when your parabola goes from opening up to opening down, that's a vertical transformation. So we're reflecting the y values. So what happens is that puts a negative out in front of the x squared. Our axis, it looks like here, shifted up 2. So for this function, we'll say g of x equals negative x squared plus 2. And if you notice this part B, it shifted to the right 3. So we'll say g of x, this one's h of x. H of x equals negative x minus 3 squared. So when we reflect it from opening up to opening down, this negative out front right here, this negative out front and this negative out front is never included in that square. So you don't want to be squaring the negative. You always want that to be separate. So in this first one, you could almost think about like that x is still in its own set of parentheses and the negative is out in front of that set of parentheses. So that gets us into that next slide, that when we're reflecting over the x-axis, reflection, it says in the x-axis, this means over the x-axis. Or you could think about it that you're reflecting your y values. Your negative is going to be out in front. This one is when you reflect over the y-axis, or when you reflect your x values, that negative is going to be inside the function. So if we were to compare the graphs with the parent function, so our parent function is the square root of x. So again, keep that reminder that your square root of x starts at the origin and then it goes this direction. So here we have the negative out front. So if the negative out front means that we're going to reflect our y values over your x-axis. So if you were to reflect your y values over your x-axis, you're still going to be at 0, 0, but now your graph will look like that. Where if you notice in part B, the negative is under the square root. So that means that you're going to reflect your x values over your y-axis. So now your graph, again, that 0, 0 stays, but now the values, these x values that you had over here, so this, it's going to reflect across this y-axis right here. So now that graph will look like that. And then part C, this is where we're going to have to talk about order. So if you notice, we have x plus 2, so this is going to be a shift to the left 2. And then this negative means we're going to reflect over the x-axis, right? Because we're going to reflect our y values. So now the order of transformations. Always start with your horizontal, which are your x values. So everything happens first with your x values. The first thing would be a horizontal reflection. Then your second one would be a horizontal stretch or shrink. and then you would have a horizontal shift. Once you've done all three of those, then you move to your vertical. And it goes in the same order that your horizontal did. So you would have a vertical reflection, then you would have a vertical stretch or shrink, and then you would have a vertical shift. And you go in that same order when you're graphing it as well. So if we were to go back to this one, and we were to start by shifting our graph to the left 2, so that 0, 0 would shift to here, and our graph would be here when we shift it to the left 2. But then if we need to reflect it over the x-axis, then that means that it would actually reflect down to here. So that final graph would be that solid red line. So then your non-rigid transformations are really just your stretches and your shrinks. So when you have that vertical stretch or vertical shrink, that's when we're applying some value to your y-axis. Horizontal is applying to the x. So when we have that absolute value graph, and remember, what's being applied vertically is actually what's happening. So here when it says 3 times the absolute value of x, the 3 is outside the absolute value, so we know it's vertical. So this would just be a vertical, a vertical stretch of 3 because we're multiplying by 3. For part B, you could say a vertical stretch of 1/3, which means you're multiplying it by 1/3. So when you say stretch, so it makes it seem like it's getting bigger. Vertical, though, because it's telling the truth, you can always say stretch with vertical. If you want to leave the numbers the same, you can say vertical stretch of 1/3. But what it really means is that you have a vertical shrink of 3. Because remember, stretch means to multiply. And if you're multiplying by 1/3, then that means that you're dividing by 3. So when we put it all together, we have, remember, your parent function here would be the square root of x. And so if we look to apply, that was for part A. So f of x equals the square root of x. So if we describe the sequence of transformations, if we go, again, starting with horizontal, right? So we're going to have a horizontal shift to the left 3. And then everything else is outside of our square root. So now we move to vertical. So now we're going to have a vertical reflection. That's this negative. We have a vertical stretch of 1/2. So we could say, again, this could be a vertical stretch of 1/2, but if you're multiplying by 1/2, it might make more sense to say a vertical shrink of 2. And then we have this -1, and then we have a vertical shift down 1. And so now when we sketch the graph, we have to put that all together. So again, starting from that 0, 0, and it might help if we were to just do a quick little sketch, right? So this red one is our parent function. And so now if we go, oops, I don't want that, I want that. If we're going to shift it to the left 3, so that point shifts to the left 3. Our point 1, 1 shifts to the left 3. 1, 2, 3, 4, and this shifts to the left 3. So we're kind of here. And then we have to reflect it across the x-axis. So now this point, I'll go to yellow. So now we're here, here, and here. So that's the vertical reflection. If we're shrinking vertically everything up by 2, that means we're dividing all the y values by 2. So this y value at 0 still stays 0, but now if it's -1, this one goes here, and the y value at -2 would go to -1. So now we're kind of compressing it by 2, and then if we shifted everything down 1, so now if this point shifts down 1, down 1, down 1, our graph would look like that. And then this last part, use function notation to write g in terms of f. So it's saying if f of x is x plus 3, if we were using our function notation, we would say that g of x equals, we have -1/2, and then we have our function, our f of x, but remember our x had plus 3, and then we would have -1. So if we were changing it back into that function notation, that's what that notation would look like.